Hi guys, welcome to my YouTube channel Smart Scorers. So our today's topic is wave optics, which is one of the important and easily scoring chapter of plus 2, that is second PU. So first, as usual, we'll see what is the total weightage of this chapter, and we'll see how it is allotted and what kind of questions can be asked from this particular chapter. And also, one of the important thing is you have a little bit of tip what I give according to my suggestion, my own experience. So please do watch the video till end without any skipping. So let's get started. So first, the total weightage of this chapter is 9 marks. Guys, 9 marks you can score very easily. And how is this possible? I'll say you for in further. So watch the video till end. So now how it is allotted? It is 1 plus 3 plus 5. So you have a 1 marker, you have a 3 marker, and also you have a 5 marker. So let's see what are the questions that can be asked in 1 marker, 3 marker and 5 marker. First, going on to 1 marker, what kind of questions can be asked? That is Haigans Principle. This is a principle, a law, and as usual I say, like, don't try to change the law, the wordings or whatever it is. Don't try to manipulate the law. Next, you have the definitions. What are the definitions that can be asked? That is wavefront, diffraction, central maxima, polarization, and pass axis. So all these definitions, all these 5 definitions are very important. Then you have Malus equations and Brewster's law. These are also a kind of laws. And coming to Malus equation, here the equation is more important than the law. So I suggest you to concentrate more on the Malus equation so that you can understand the law properly and you can also write it very well. So this is all the 1 markers from this chapter. Now let's see what are the 3 markers that can be asked. 3 markers is Doppler effect. This is a theory kind of question, so you need to explain it very nicely. How nicely you explain along with the graphs, along with the diagrams, whatever it is. So how nicely you present is what the thing that matters, like that is the thing that can fetch you marks. Next, you have variation of intensity of interference or diffraction with respect to phase difference and path difference. So here this is basically talking about the graphs. Like, you should know where the graph goes to maximum, where the graph goes to minimum, and why it is going to maximum. All these conditions and all, if you know, that is very important. Then you have uses of polarites. Minimum 3 uses are a must. Then you have polarization of reflection and you have polarization of scattering. So these two are also theory type questions. So how nicely you present it on the paper is what that matters. So this is all the 3 markers. Now going to 5 markers, you have refraction and reflection of wavefront at a plane surface. So this is a kind of theory question with diagram. So you need to specifically mention the diagram for refraction or reflection, whatever the question is asked. Then you need to explain that very beautifully. Then you have theory of interference of light. Again, this is also a theory type question. Then you have YDSC, that is Young's double slit experiment. So here what you are supposed to do is, it is a derivation where you need to find the fringe width. So you need to find the fringe width from this YDSC. The next type of question, the fourth one, is the numerical. They can also ask you numericals from this chapter. Now let's see, I was talking about a tip at the starting, right? So what is the tip? The tip from my side is, in optics, that is ray optics and wave optics. So I said both will have numericals, both will have 5 marker questions also. So how is this coming? It is like, if the theory question, the long answer type question comes from ray optics, the derivation comes from ray optics, then the numerical will be from wave optics, or vice versa. It can be the other way around. If the derivation comes from wave optics, then the numerical will be from ray optics. And here, what kind of numericals are asked in wave optics is major and basically on YDSC. So many numericals are asked only on YDSC, the fringe width. So if you derive that properly and if you know how you can use that properly, then yeah, you can do all the numericals given from this chapter also. So this is all about in this chapter, and if you like this video, please do like, share and subscribe. Thank you.